This is the book 50 Challenging Problems in Probability, and this is number 19, Isaac Newton Helps Samuel Pepys. Pepys wrote Newton to ask which of the three events is more likely. A, at least 1 6 when 6 dice are rolled. B, at least 2 6s when 12 dice are rolled. Or C, at least 3 6s when 18 dice are rolled. I think it's good to start off by defining our states. So we define our states A, B, and C. Now first, let's find the probability of A. 9 times out of 10, when you see at least, you should probably be using the complement. The complement of at least 1 6 is no 6s. And for all three of these cases, we can think of the amount of 6s we get like a binomial random variable. So to calculate the probability that we get 0 6s, it's just 5 6 to the 6th power, because if every child is a 5 6 probability, we don't get a 6, and we want 6 of those. So when we compute this, we get about 0.6651. Now let's calculate the probability of event B. Again, we see at least, so we should probably be using the complement. The complement to at least 2 6s is 0 or 1 6. So the probability we get 0 6s and 12 dice rolls, again, is just 5 over 6 to the 12th. And then the probability we get 1 6 and 12 dice rolls is 12 times 1 6 times 5 over 6 to the 11th power. Again, we're thinking about this like a binomial random variable. If you're not familiar with binomial random variables, you should watch my video on binomial random variables. But just to summarize, if we have 12 trials, we need one of them to be a 6 with 1 6 probability, and then the rest of them, the other 11, to be not a 6 with 5 6 probability. And there are 12 different ways we can do that. So that's where we get this 12 from. When we add these two together, we get 0.3813, and then when we compute our final result, we get 0.61866. Now, let's finally calculate the probability of event C. If you haven't noticed by the pattern already, we're going to again use the complement. The complement to at least 3 6s is 0 6s, 1 6, or 2 6s. The probability we get 0 6s and 18 rolls is just 5 over 6 to the 18th. The probability we get 1 6 and 18 rolls is 18 times 1 6 times 5 over 6 to the 17th. And then the probability we get 2 6s from 18 rolls is 153 times 1 over 6 squared times 5 over 6 to the 16th. And that 153 is just the total number of ways we can select 2 from 18. So essentially selecting 2 6s from the 18 dice. And when we sum these together, we get 0.40265, and then our final answer is 0.59734. So back to our original question, which of the three events is more likely? Event A has the highest probability, so it's the likeliest. Thank you.